In this tutorial, I'll look at the discrete probability distributions, and the ones we're going to consider are the binomial distribution and Poisson distribution. First, let's recall our convention for naming these distributions. It gives them a base name, and the ones we're going to consider here are Poisson and binom, for binomial and Poisson distribution. Then the prefix, single letter prefix D, gives you the points along the curve. P gives you the probability, which would be, it will be used as the less than or greater than. It's really not the area under the curve for a discrete distribution. It's a sum of the probabilities to the right or to the left. And we're not going to worry about these two right now, but Q and R are the other two prefixes. For the binomial distribution, recall that we're looking at a case in which you can have two outcomes, either win or lose, essentially. And you know the probability of a win, and that's generally denoted P, and then Q is a probability you lose, which is 1 minus P. Obviously, you don't need to put both of these into R. That's sort of redundant. So you need to specify P, and that's specified in your binomial distribution as a probability. So you have to specify that. Okay. Then you have to specify the number of trials, the number of attempts, the number of games in the tournament, and that is size. Okay. Sometimes that's an N, but in R it wants the size. That's the size of the tournament, essentially the number of games you're going to play. P is a probability you're going to win one of those games, and probability of winning one game, and 7 are the number of games you want to win. So when you get the binomial distribution, you're going to get what you're looking at. Binomial distribution is a bunch of plots because it's discrete, and so you're looking at this value right here, which gives you the probability of 7 wins. Well, that doesn't look like there'll be 7, they'd be over here somewhere. 7 wins out of a trial of 10 if the probability of winning one game is 0.4. And that's what you returned with the D. Okay, you can plot these if you make some graphs, like some arrays for the, as I did for the continuous distributions. But what I'm going to look at right now is just finding the probabilities. Okay. Now the other thing you might look at are, we're going to call them cumulative probabilities. That's the probability you would win. Say you want to find out the probability you win at most 7 games, or the probability you win at least 7 games. And if you recall from doing this by hand, you had to find for the at most, you would have to find the probability of 0, 1, 2, 3, 4, 5, 6, 7 and add them all up together. Alright. And for the at least, you could take that and subtract it from 1 and you would get the at least. So you'd have to do this calculation by hand with a bunch of additions. In R, instead of that, you can use the Q. I'm sorry, not the Q. Use the P. So here we use D to get the point along the curve. P is going to be the sum of all those that are less than, unless you specify the lower tail equals false. So here I'll type these commands into R. Let's say I want to find the probability that I'm going to win 3 out of 5 games if the probability of winning 1 is 0.2. So I'm going to use D to get that particular probability. And then I type that it's a binomial distribution. I want to win 3 out of 5 games, so 3. You will see examples on the internet where people don't name these variables as size. They just put them in an order. Very dangerous thing to do because you can invert the order and make a whole different situation. Okay, so the size, I'm going to have 5 games. I want to win 3 out of them, and the probability of winning one game is, let's say it's 0.15. Alright, that's it. And I'll get that back. About 2.5% chance I'm going to win 3 games when I have that low of a probability. Okay, so now if I want to win at least 3 games, I will use the P, because that's going to add up the cases below it. And have to specify all this every time. It doesn't. There's no defaults here, and this will be, put a sharp here for a comment, and this is going to be at least, no, at most 3 games. I'm doing at most because it's going to be everything less than it. So I could get 0, 1, 2, or 3. All right. What did I do now? I misspelled probabilities. So I go back up here, and I just don't feel bad about it. I just fix it. Okay, there we go. Well, that's pretty much, that's all I'm going to get is 3 games at most. Now what if I want to do at least? Same calculation, but this will be at least. But I just specify that the lower dot tail equals false. This will be at least 3 games. That would be, I might win 3 or 4 or 5 games. Highly unlikely, right? And that's what I get. And as you expect, those 2 numbers add up to 1. I'm going to continue here and look at the Poisson distribution. Recall the equation for the Poisson distribution. It requires a lambda, which is an average. And so in the Poisson distribution as specified into R, you must specify the lambda. Let me write the equation here for the Poisson distribution probability. So this is the Poisson, and it has to have an average value of lambda that's consistent with the units you're using. So always watch for that. E, Euler's number, to the lambda times the value you're looking at. I should put a y here. Y to the, this is negative. Okay, I guess I got to start this over again. Let me do that. All right, this is that's one thing about these distance classes and watching videos. You never see anybody make a mistake. That's why I don't take all the mistakes out of here. Because what's more important, never making a mistake or knowing how to recover from a mistake? Knowing how to recover from a mistake is crucial. So how do you do it? Well, just fix it up. Okay, in math, it's not as much as trying to be in search and rescue and fix up a mistake. I want the Poisson probability distribution for some value y, a case where the lambda is the average. E to the minus lambda, lambda to that y value over y factorial. And you remember y factorial is y times y minus 1 times y minus 2 all the way down to 1. So 5 factorial is 5 times 4 times 3 times 2 times 1. And of course calculators have the factorial button on them. But that's important. That factorial is important in case you forgot that from algebra. Okay, so how do you do this in R? So in R, if you want to find a particular y value, you can just, okay, so let's look at finding the Poisson probability that, let's say that the average number of babies born in a hospital is, say, 12 per night. And you want to find the Poisson, so using Poisson distribution, find the probability. So it's 12 per night. Let's say that 10 are going to be born that night. So put the 10 here, you give it the lambda of 12, and you spell it right. Okay, there you go. A 10% probability. So if you want the probability that at least 10 will be born, you can use P. And because we're using at least, we have to go lower tail equals false. So at least 10 are going to be born that night. How about the probability that at most 10 were going to be born? I can just change this to true or take it off altogether because that's the default, and there's a probability that at most 10 are going to be born that night.